Hey squad, welcome back. Sorry I dodged you on 4.2. We're going to take a quick little intermission to watch a bit about video games. One game in particular, The Legend of Zelda. And this will eventually tie into dealing with triangle congruence, and you'll soon see maybe how this came to be. So I threw that in there because one, I just wanted a detour of video gaming, and two, because I thought it was interesting how I've seen this logo of these three triangles from those goddesses in Zelda forever, but only in geometry do we see that by reasoning, we can actually say that this triangle is congruent to this triangle and congruent to this triangle. The portions that we saw previously, I believe, were side, 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 and I think side, side, angle. Yeah, side, angle, side. So previously you saw just side, 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 and then side, angle, side. And I didn't teach that one. I had a guest step in for me. But now we see another way that we can see if triangles are congruent or not, starting first with angle, side, angle postulate. This states that if we have two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So this is based around how these two triangles have angle A congruent to angle C, angle D congruent to angle F, and also the side measurement, or the side measurement of DF congruent to this side AC. So if we're allowed to say that angle A could be congruent to angle D, and if we can say that segment AC is congruent to DF, this allows us also to say angle C is congruent to angle F. Just based off of that, we're allowed to say collectively that based off of angle side angle, triangle ABC is congruent to triangle EDF. That's safe to say. So this is just another tool that we can use in addition to side, 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 and side, angle, side. We can now use the idea of an angle with a side in between another angle, and if we have angles that are congruent on the other end of things, we're allowed to say that they can be congruent because of angle, side, angle. With this example seen here, we're being asked to use angle, side, angle and explain if these triangles are congruent or not. So this may be a little tricky, and I encourage you to rewrite these if you can. Well, what we're looking for is similar to up here, how we want an angle, and then on one side it's a side that's congruent, and then another angle. So we're looking for that kind of setup. So I know that HOG, here it's saying that H could be congruent to N or A. I know that they have the side segment in between these two angles here, and I know we also have it here. So based off of this, we're allowed to say that triangle HGO is congruent to, what would that be, the ACT. So we're allowed to say that. Or you could also put this as hog congruent to triangle cat. Wait, can you say that? No, you can't. Sorry. Scratch that. This is fine. So this is one way that we can prove triangles are congruent. The other way we see is with angle side. So based off of this, we can say that if two angles and a non-included side of one triangle are congruent, the two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. So we have angle side. We always kind of take this around the way. So if you start with one angle, take it the rest of the way to the next angle, and then find that side. So based off of this, we can say that triangle BAC is congruent to triangle EDF. And this is again based off of how angle B is congruent to angle E, angle A congruent to angle D, and the segment AC congruent to DF. Those are fair game. Collectively, when we can say this, we're allowed to say that the triangles are congruent. In these situations here, we're being asked to decide which, if any, of the triangles below are congruent. If possible, justify your answer and write a congruence statement. So recall that we now have the option for angle, side, angle. We also have angle, side. So chances are this is probably what they're hinting at. All right, so let's say that we wanted to start and look at triangle ABC. Well, we would want the single angle measurement, then the double, and then a congruent side. So let's think. Let's start here, then travel to here with this second angle, then conclude with this side. All right. So do we see another triangle that has the one dash for the angle, two dashes for the angle, and then a congruent mark for a segment? Well, if we tried this, this is just going to hit the 1, the 2, and then there's nothing here. So this doesn't necessarily work. We can go down here. Well, we have the single for H, then we have G, and then we go to I. So this could be congruent. So let's do HGI. And we can say that these are congruent by angle, side. Seems pretty easy, I think. Not much arithmetic. We're being asked here, are FAN and SGN congruent? Justify our answer. So FAN is right here. This has an angle, and then a side. So chances are we could probably do this with angle, side. So we could say that angle F is definitely congruent to angle S. We can say that FNA can be congruent to S